In this video, I'm going to give an overview of section 1.2, which is on the echelon forms of a matrix. So the key goals for this section are, so first we'll talk about what an echelon form is and what a reduced row echelon form is. So I'm going to be using those terms so often that I have abbreviations for them. So the echelon form, I'll call it EF. The reduced row echelon form, I'll call it RREF. Sometimes, to make that even shorter, I'll just call it REF for reduced echelon form. Okay, so we'll talk about what those are and how to get a matrix into those forms. The second goal is understand how we can solve a linear system. So how do we find the general solution to a linear system? By row reduction, using our row operations and converting the matrix into echelon form or into reduced row echelon form. And the last learning goal is to be able to figure out when a system of linear equations has either zero solutions, one solution, or infinitely many solutions. It turns out a linear system of equations will always have one of these three possibilities. It can't have like a different number of solutions, like three solutions. It's either got to be 0, 1, or infinitely many. When a system has zero solutions, we call that inconsistent. When a system has at least one solution, so that's when it has one solution or infinitely many, then we say the system is consistent. And we'll define those terms more formally in a later video of this section.